Hello everybody. Our next speaker has a background in physics. This motor has evolved over a 4-year period and will be showing a detailed description of how to build it yourself. And not only that, but a live description of how it works and how it saves electricity. So, without further ado, I would like to humbly present Reginald Miller.
Thank you. Well, what we're going to demonstrate here is a drain test, and it's the basis of the efficiencies that I claim for this kind of a motor. So if Gloria would help me, we'll just start the motor spinning. We have 2 sets of batteries. We just unpacked them. The batteries were shuffled by John. So that's the motor I built. It's got a large permanent magnet in it and coils with a lot of windings. The other motor is an AC induction motor. You buy these off the shelf in a hardware store. So I'm claiming efficiencies of 10 times what you get at 500 RPM and higher efficiencies at lower RPM. Let's see. No. This one. The voltage. Did you press this? There we go. Do you have the RPM meter, Gloria? You could take an RPM reading. To make an equal test, you try to run the motors at the same speed so that they have the equal load. They have an equal propeller on the shaft, and the even the aerodynamics, I worried about that. That's why there's a square box on this end. Doesn't work? Oh. So what do we have? Okay. Okay, so this fan is going at 570 revolutions per minute, and the other one is going at, what, 530, 540, Gloria? 516? Oh, 526, okay. They're a little unequal. We have a correction curve for inequalities like that. You know, it's hard to hit exactly the RPM. So the idea of this is to just count. She's recording the time. So at regular intervals, we'll take RPM reading, and the efficiency will simply be if the last go lasts 1 hour and the other motor lasts 10 hours, it should be 10 times more efficient. Now, I guess you can see the meters. The fan from the hardware store is 12. Everything's backwards here. Let's see this. Okay. It's 12 volts at about 6 amps. So that's about 60 watts, say, 65 watts. And the other meter is reading 1/10 of an amp at 70 volts. So that's about 6 watts. And then it's a pulse motor, so the meters lie a little bit. It's even better than that. It's not draining all the time. So we're just going to let that run, and I'm claiming this is an improvement in motor design, and we're going to run a video now, and the video will have something to do with product improvement, and at the end of the video is a shot of the motor running at over 1,000 revolutions per minute. So if you could run the first video.
photographs of hand trucks of all sizes and functions. There were contracts for other products related to material handling, such as loading ramps, dock boards, and safety items. As the products proved their value, the result was a seeming unending variety to fit the demand. One good idea that could have been pursued was the lightweight walker. It's an interesting fact that my grandmother was probably the first person in America to use a magnesium tubing walker. The walker was never pursued, however, because Magline had more business than it could handle, and the idea didn't fit the materials handling category. So it was given away without patent protection because Dad thought it was something too important for people not to have. However, lucrative military contracts were included in the mix. There were contracts for rocket fins, rocket nose cones, satellite frames, clips for parachute harnesses, cooking pots and pans, just to name a few. During my college years, I worked summers at Magline. The Quonset project was just tooling up. This was a package that could be airlifted to location, and in a day or two a complete building would snap together and an insulated covering would provide climate control. I did fit and function engineering on the drilling jigs and corrected several errors. Magline had a successful run with this and other contracts in the late 60s and early 70s. At the peak, employment soared to over 600 workers. Magline products can be seen everywhere in America. In fact, the products are sold worldwide, and the whole venture started with the simple idea to make children's furniture easier for them to move around. Raymond V. Miller provided ideas and venture capital for several businesses, but will always be known as the co-founder of Magline. His simple philosophy was, feed the birds and do something for your community. This leads to the demonstration at hand. The Lasco company has been making floor fans since World War II. Grandmother had one of these large floor fans, and I remember as a kid hovering around the floor fan on hot days. It was so large, approximately 25 pounds, that I could hardly move it. The Lasco company improved their floor fan product. An economical and lightweight version called the portable box fan has emerged. The amazing product is available in any hardware store and also in many grocery stores. This demonstration is between this 5-pound lightweight Lasco box fan driven by an AC induction motor and the same box fan fitted out and driven by an unusual 20-pound dielectric motor. However, we have just seen Progress strategy go from heavy and bulky to light and slender. So we expect our gadgets to be light and powerful. The heavy dielectric motor apparently doesn't fit the picture. But things are changing. High efficiency is in demand, and the dielectric motor has amazing high efficiency. At 530 revolutions per minute, the dielectric motor has an efficiency of 9 times that of the typical AC induction motor. This efficiency even improves at lower speeds. At 300 revolutions per minute, the dielectric motor is 20 times the efficiency of the AC induction motor. Here is a video of the dielectric motor turning at a fast speed of over 1,200 revolutions per minute. Although the efficiency of the dielectric motor drops at high speeds, the prototype is still observed here to be turning 5 times more efficient than the AC induction motor. Let me get the number. I'll come around the front. Are you ready? You see that? I had a 12, 14.
Okay, so a little bit, I'll show you some details inside of the motor. But I wanted to show you something on pollution. This is why I'm doing what I'm doing. And you're going to see a little clip here of, on Thursday we were talking about the Tesla's radiation, to fill up the airwaves with radiation. And I believe that was done by the Atlanteans many thousands of years ago, and they used a frequency of 10 to the 12 cycles per second, and that won't hurt living organisms. So we could watch the next video.
The standard theory regarding the Egyptian pyramids is that each pharaoh of the Old Kingdom built a pyramid tomb monument. Originally, the monument was a single-story rectangular mastaba with an underground complex hypogeum. But then, 4,600 years ago, Pharaoh Zoser added more stories to his mastaba, and its form changed into a giant 6-step pyramid. Zoser was the first pharaoh to use agglomerated stone, essentially pouring concrete into forms, thus decreasing construction costs by a factor of 100. The next pharaoh built an 8-step pyramid. The monument form eventually became the smooth-sided pyramid. These monuments grew in size, some adjacent to others, in great complexes. By the end of the Old Kingdom, the Giza complex had 10 large and small pyramids. The scale of this complex alone boggles the imagination. Could only gods build such wonders? However, a competing theory exists. If one looks at the Giza pyramids and goes back in time with an imaginary time machine, the pyramids do not disappear in the order expected. The standard theory would say that the largest pyramids, the last built, would be the first to go, but notice the small pyramids disappear first. The last pyramid standing is the largest pyramid. Looking at the dial on a time machine reveals that this pyramid is an amazing 52,000 years old. In this alternate theory, the Great Pyramid was always there. For thousands of years, generation after generation, had this pyramid and identical ones around the world to look at and wonder about. Stories always existed about the power and glory of that long ago society, The original ones from out there, the Atlanteans who landed and built it. It wasn't a tomb monument for them, but a necessary and vital piece of equipment that supplied their electrical power. It also served as their distant communication device. Thirdly, it memorialized the values of time, weights, and measure, units that are still used today. The non-polluting civilization used their dielectric generator for 3,000 years. Is there evidence for this claim? With a little consideration and by sketching in parts that were once there, the unmistakable remains of a huge complex machine is revealed. In their concept to honor the diversity found in the universe, the marvel was designed to harvest natural energy using several different methods like thermocouples, hydrogen oxidation, piezoelectricity, focusing the Earth's vortex, all to generate electromagnetic power. Every power generator needs an output control, and the pyramid was no exception. The mysterious sloping grand gallery was not there to thwart grave robbers. The portcullis gates and other machinery used out-of-phase energy to moderate the output. The ever-changing position of the sun and moon needed consideration, so this equipment was necessary. Let's look at piezoelectricity. Where does the spark come from to light the fuel of the cigarette lighter? Answer: a spring-loaded hammer stresses a piezoelectric crystal. This upsets the neutral balance of charges in the crystal lattice, resulting in the high-voltage spark. Piezoelectric crystal pickups for phonograph players are vibrated by tiny wiggles in the record's groove. Small plates on each side of the crystal collect the electrical energy that is amplified to drive the speaker. The diagram shows a single stressed crystal compared to a neutral crystal. Notice the distribution of electrical charges before and after the stress is applied. Consider two crystals glued together to make a long crystal. As long as the glue is a dielectric like calcium carbonate, the assembly will behave like one long crystal. The amount of deflection is highly exaggerated for clarity, but consider a motor flexing the crystal back and forth as shown. Notice that the electric charges will alternate. Alternating change in polarity is what happens in a radio antenna. The result is an electromagnetic wave radiating away from the antenna. And the same principle applies to our elongated crystal, and an electromagnetic wave radiates from the crystal face as long as the motor supplies the deflection energy. A radio antenna will radiate energy even if coated with a dielectric material. The electromagnetism passes right through the insulator. The same principle applies to this long rod composed of a multitude of embedded piezoelectric crystals. Multiple crystals coated with a dielectric glue, like calcium carbonate, will still radiate the electromagnetic energy as shown in the diagram. Now one can imagine other geometries besides long rods. A wall of the same quartz embedded calcium carbonate matrix will radiate an electromagnetic radiation as long as the motor supplies the deflection energy. The motor could be replaced by any source of reciprocating energy, including a windmill, but as will soon be shown, that won't be necessary. The rectangular wall can be trimmed into a triangular shape without altering the electromagnetic radiation property. It is now a simple step to imagine four huge triangular walls assembled into a freestanding four-sided pyramid. The triangular shape and the corners make an earthquake and windstorm-proof structure. Get the facets oscillating back and forth, and the center of the Great Pyramid would fill with an intense electromagnetic radiation. The only question is, what mechanism can be used to deflect the faces of the Great Pyramid? If we consider the wind, which oscillates flags, if one examines a flagpole in a strong wind, it oscillates back and forth at its resonant frequency. Sometimes a strong wind will make a sliding glass door, especially if left slightly open, hum at its resonant frequency. The fact about wind is that any membrane stretched and held in place in a strong wind will oscillate at its resonant frequency. The material of the membrane is irrelevant as long as the thickness to length ratio is at least 100 to 1. The 6-foot thickness of the casing blocks is based on several still in position at the base. The length of the wall from the base to the apex is 600 feet. So the ratio is 100 to 1. This membrane, because it is held rigid at all edges, will naturally vibrate at its resonant frequency. For the facets of the Great Pyramid, that oscillation is 12 cycles per second on wind energy alone. The Great Pyramid was a stationary inner core pyramid surrounded by an outer vibrating pyramid. About 1,500 years ago, the outer pyramid, unfortunately, was used as a quarry to supply Cairo mosques with building stones. Only a few casing blocks remain along the base. The purpose of the inner pyramid was to convert the 12 Hz electromagnetic radiation of the outer pyramid into the final and extremely ultra high output frequency. The gap is the most misunderstood missing piece. It is absolutely vital. Without a properly designed gap, the outer casing would collide with the core pyramid. On a windy day, the Empire State Building flexes 8 feet at the top. The relative position of the apex of the pyramid moves under the influence of the wind, the position of the moon, and the sun. On a sunny day, at the correct time, the shadow reveals the recess in the south-facing facet. The French savants measured the recess, and it is identical on all 4 faces. The existence of the gap cannot be denied. The King and Queen's chamber were resonant to electromagnetic radiation, and they worked in harmony with each other. The complexity is beyond this brief introduction. However, the King's chamber mixed out-of-phase frequencies. The mixing of electromagnetic frequencies creates the difference and the sum of frequencies in the resonant chamber. It is an engineering principle. Notice the stones above the King's chamber, the so-called attic chambers. The bottom smooth surfaces and the floor of the King's chamber form 5 overlapping resonant chambers. The so-called roof is a reflector to force unmixed frequencies back into the mixing chambers. There is, in fact, yet another reflector for this purpose. It was the gold alloy apex over the casing blocks. The hieroglyphic symbol for the pyramid looks like the letter A, and the apex is always colored yellow. Mixing different frequencies creates high frequency and high amplitude. The ultra-high frequency caused by the mixing activated the crystals in the granite walls of the King's chamber, the mixing chamber. These vibrating crystals release the final output energy. The limestone and other dielectric materials of the pyramid are transparent to high frequencies. The output energy travels straight through the mass of the pyramid and radiated out across the country. The radiation pattern of 18 pyramids filled the planet with enough electromagnetic radiation to power distant equipment. Flying machines could circumnavigate the globe. Each pyramid could support the needs of about 75,000 people, and this was sufficient for the small outpost on planet Earth. "49,000 years before current time, Earth experienced a rare encounter with an extra-large meteor. The impact caused Earth changes. One of these meant that the electromagnetic upwelling that powered the pyramid began to move, spelling the end to most of the pyramid power. Great earthquakes shook the land. Dormant volcanoes began to vent. 98% perished at the onset. Dust darkened the sky. It was the beginning of a 400-year epoch of unstable climate. Desperate survivors first struggled against torrents of rain, and then the planet cooled and the rain turned to snow and ice. Survivors huddled in caves, wrapped in animal skins. Every meager scrap of food was consumed. But the Atlanteans were not the only ones in the caves. The Lemurians, who were the early Cro-Magnon species, the precursor to modern man, were already living in the caves. And for the first time there was the opportunity for mixing. The Lemurian males found the Atlantean females entering their caves to be sexually attractive. The Atlantean females didn't have a lot of choice in the matter. It was instinctual for these females to raise the descendants of these encounters. The joining with polite beings that had advanced abilities, the process to dream of making things for the future, changed the Lemurians and in fact created a new species. The accidental event did not go unnoticed. Besides the Atlanteans from Sirius B, scholars from many planets had been studying for many centuries their precursor species directly on the planet of origin. That planet, of course, was Earth, and now the intensity of this study would increase, for it was soon discovered how interesting the new species was. Tool-making ability skyrocketed, and the road to high technology began. However, the new species proved to have an apparent flaw. The adrenal gland, inherited from the Lemurian, gave the chemical signal to awaken the brain for emergencies, the preparation for fight or flight. Disputes over food and territory was not settled by the natural sharing and compromising traits of the Atlanteans, but was increasingly settled by the one who had the best weapon and the boldness to use it. The adrenal chemical stimulation also led to the endless search for new possibilities in every respect, from tool-making to exploration. The range of emotion increased from the extreme depths of unbelievable fears to the incredible joy of conquest and discovery. An experiment was conceived in the minds of the scholars from out there. What would happen if this reactive species was seeded with those from different planets? Would the slight differences cause war, or would they learn to cooperate? This answer was vital because obviously these new ones would eventually learn to travel and explore the universe. Would they move through the universe and conquer peaceful races already out there? Or would they come in peace and cooperation? Seeding began thousands of years before recorded history. The grand experiment led to civilizations scattered around the globe. When they met, the result did many times end in war. There is, however, in recent times, a cooperation among mankind and warring reactions are becoming isolated events. Everyone is part of the experiment. Controlling the impulse to settle differences by war is the goal. Accomplish this, and we will be invited to join the others and see for ourselves the great star cities. The Second Cataclysm. Many attempts at city and state building came and went. However, one notable civilization existed 10,000 years ago. Unfortunately, another huge, dense, fast-moving object entered the solar system. The scientists saw it coming, but there was confusion over just how to prepare. In the end, it just passed by without a collision. However, the close pass affected gravity 1,000 times more intensely than the moon does. All great bodies of water surged over their banks and smashed everything they encountered. This is the time of the Great Flood, and the event is recorded around the globe in all ancient texts. Again, civilization was largely destroyed, but a few survived on the mountaintops. Life began anew, and that brings us to our time now. The effects of the third cataclysm are being felt right now. This event will not be over in 3 days. You might say this is a 300-year event. It has to do with the technology that has been adopted globally. The use of fossil fuels and the type of chemical industry that creates products without understanding the full consequences has to do with our unchecked population growth and the fact that soon everyone on the planet will want those products. The problem is that most of the products desired have one or more atoms of oxygen in the formula. The oxygen is extracted from the atmosphere as if it is an unlimited supply. But it is a finite source, and it is only replenished by the forests and ocean organisms at the rate of about 0.05% per year. That rate has already been surpassed, and so the free oxygen is starting to decline. The early warning is given here because without early attempts to correct it, the problem will overwhelm future attempts to change it around. We are told that CO2 is the problem, but don't worry because there is a big idea to bury the problem. But the reality is that the chemical industry creates 70,000 different chemicals, and that translates into 1,500 million tons of plastic products on a global basis. Of that, about 305 million tons is the oxygen molecule taken directly from the atmosphere. This is the amount of oxygen in a 50 square mile block of atmosphere. And essentially it's eliminated forever because once bonded, most of it is buried, and even if recycled, it doesn't release the oxygen back into the atmosphere. The increasing use of products by the people of China and Asia in the coming years means that this oxygen depletion doubles every 5 to 10 years. Exactly how fast the doubling will occur is an open question. However, if you take a look at these values and extrapolate, it'll all be gone within 400 years, but even by 200 years or less, everyone will be gasping for breath and will be living at sea level, where the last remaining breathable oxygen will exist. Will we wait for that time when industry will be selling us oxygen in our hermetically sealed homes? Or will we figure out that something has to be done now? The acronym GEOD stands for Global Expanse, Oxygen Depletion Everywhere. This small group is attempting to educate and start the discussion on possible cures. The first phase is to list the molecules that are robbing the atmosphere of oxygen and bonding it up essentially forever.
To build a windmill blade or build an electrical generator for the windmill blade. In the production of copper, you use a lot of oxygen, but that's considered profitably sequestered oxygen. But to continue to use, when you buy something and it's enclosed in a big plastic packaging materials, it's used once, it goes into the landfill, then you've used oxygen and it's gone and lost forever. So if you've noticed, the one fan has finished and the other one is still spinning, and we'll just keep watching it and see how long it goes. Normally when I do this, at this speed I get 10 to 15 times the efficiency. And now I'd like to show you a little bit of how this came about. Let's see. Gotta do something over here. I guess I need this. There's a way to get back to Keynote. Keynote. So I can go through slides. Okay, yeah, that's it. That's it. Okay, the first thing I did was put these little coils come from like Radio Shack or Willie's Electronics. They're little bobbins of magnetic wire. I put an iron bolt through the bobbins, and I found leads on each bobbin by cutting into the bottom. I had to solder to find the bottom lead. The idea there was this way I didn't have to do any coil winding. And I discovered that if you use one, I just put a, this was before I did a motor. All I did was a pull test. I had a spring scale, and I think it was a 1 pound pull, And if I use 2 coils in series, I got the same 1 pound pull, but I was using half the energy. And if you use 4 of these in series, you get a 1 pound pull, and you're using 1/4 of the energy. And this was in Joseph Newman's book. This is kind of what turned me on. So I wrote an article, and I got a little response. Someone wanted to know if I could build a motor with it. I don't know if you can read this, but at, see, for example, at 1,000 ohms, you're using 12 watts. At 4,000 ohms, you're using 3 watts. So that's the basic idea of this motor. So my first motor was a disc, and I used 4 refrigerator magnets. They're very weak, but this motor would rotate. I made this commutator, the axle switch, was just a disc of copper with cutouts in it, so the coils would be timed at the right place, you know, to get the thing spinning. I noticed right away the large sparking. There's kind of an echo. What is that? The first thing I noticed was sparking, a lot of sparking. So my focus was to get rid of the sparking, and I came up with this motor tester. And I used a reed switch in this with a transistor, and that helped quite a bit. This is a coil. I made 12 coils so I could replace the coils quickly. This part here is timing. The thing would rotate. I discovered that the reed switch was very sensitive. You had to have it just precisely timed. This over here is for horsepower, to see how much horsepower it had. This idea came from Peter Lindemann literature, and I learned how to use a spring scale to, you know, measure the drag and so on. And that way I could determine, you know, oh, these coils, by the way, have an air core in them. And I was putting iron, soft iron in them to test the effect of, you know, iron core. And this was a Bedini idea. I was beginning to use diodes and collect the back EMF from the coils. Here's the circuit I evolved. I didn't know much about transistors. It took some doing for me to figure this out. And I did over 100 experiments with the transistor before I came up with this system here of determining the value for this resistor here. It was very critical. So anyway, I made progress, and here's a little circuit I developed to find out something about the coils. There's a little coil symbol right here, and I would put a coil in there, and for instance this one, here's a long narrow coil, and it was air core, and I could put one wire or many wires, up to 90 wires in there, and the inductance would go up as you put more iron wire in it. But also this circuit back here has a diode going into a capacitor, and here's a voltmeter over here. So what I would do would be to activate the switch with my finger, maybe 2 times a second, and measure the collapsing field from the coil that would go into the capacitor and measure it by the voltage. So this, whoop, get used to this thing. Right here. These curves here are, this bottom curve is with no iron in whatsoever, and this top curve is with 90 soft iron wires in the curve. And what it means is that with one pulse, this is approximately 6 volts running, going into the coil, you'd get about 8 times that, almost 50 volts coming out. So when you use iron, the back, the collapsing field can be quite large. And if you're going to run a motor at 400 or 120 volts, 8 times that, you're getting these 1,000-volt pulses out of the coils. And this is one of the reasons why they use low-winding coils. These motors are highly efficient when you use a lot of windings, but they you have to worry about this collapsing field. So one thing you can do is leave the iron out, and then the collapsing field is exactly equal or a little less than the energy going in, the voltage going in. So that's the direction I took, and I came up with some principles here after playing around with this motor tester. And one is to use, also I noticed the core of the motor tester, you could put different rotors in, you know, and I was testing different size magnets, and the efficiency would go up with larger, more dense magnetism, permanent magnets, and the efficiency would go up the more windings that you used. And I had some success with using Bedini's idea, you know, with collecting the collapsing field into a recovery circuit. So that's one of my principles here. And of course, this particular motor is run by brushes. It's very simple. It's as simple as you can get, but this brush could be wired into a circuit and you could run most of the energy through a transistor and there would be no sparking whatsoever. So using, you know, solid state switching techniques, I've also had my motors run with Hall effect and with photo opto-interrupters. And along the way, I wanted to experiment with motor iron, you know, laminated motor iron, and I couldn't find a source for, you know, a couple pounds of it. They wanted to sell me 2,000 pounds, so I looked around and I discovered a better material. It's 3% more efficient than motor iron. And I used it in this little device. This is a little something it's a battery charger that has iron in the coil. And the idea there is to get a nice pulse coming out of the coil when the motor shuts off or is, you know, cycling through. And that goes into right here. This is the little tiny motor. Has iron in the core, and the diode drains the collapsing field into this capacitor. And I discovered that you can use non-rechargeable batteries will recharge. And you can, one of the tricks is to have a timer on it. The reason they say you can't recharge a rechargeable battery is because you charge them too fast and they do warm up and they can split apart. But if you do them in little tiny pulses like that and use a timer, you can recharge your Duracell batteries. I always buy Duracell because it's a $4 battery. This top line is what you would get out of a Duracell, a fresh one, a brand new one. If you recharge it, you get this line here. Actually, it went a few extra hours, but area under the curve calculated out to 97%. And this curve here is a $2 battery. So they look similar, but when you test them, they're worth $2. So here's the motor. Here's some details on the magnet. The top, first of all, I used 5/8 axle, steel axle, simply because it would fit inside of a extrusion that you can find in hardware stores. The extrusion has a 3/4 inch outside dimension. So these 3/4 by 3/4 by 3/4 neodymium magnets fit snugly in there. And then I put a 1 inch by 2 inch by 2 inch neodymium magnet on each side. And that's about a 4-pound magnet. And if you notice the revolution here, the corners determine the distance from the coils. And I thought this would be a weak point here, so I filled this in with iron. And when I did a pull test, it made sense. But I found out later on that I actually got more efficiency by taking the iron out. We run out of time? Well, that's the way
I would never say that, especially now we're on a roll like this. How much time do you think we got left?
Well, you could just, they're seeing the results here. You know, it's just more and more details. You got, at low speed, I want to say one thing. Okay, at low speed, this will be more than 20 times. At a lower speed, it'll be 35 times. And I've actually gotten, here, let's see if I can find one last, going the wrong way. One last graph here. It's too bad this is, no, I can't find it. But I've had this motor up to 8,000% efficiency at 100 revolutions per minute. And what I want to say is, at that efficiency, if I give a 20-minute demonstration, I can say that it's putting energy in the battery. But if you see a demonstration, ask yourself, how long is the demonstration, because in time, I think all of these devices will drain the battery like this does. But if you're getting 10 times over, you're getting 10 times over. That's a step in the right direction. You could in there, if you want to play the last video. Is there time for that?
Pardon?
Is there time for the last video?
How long is the video?
3 minutes.
3 minutes? Everybody have time for 3 minutes video?
This is, we knew we'd be coming here where it's hot, so this is our cool idea from Michigan. We live in Michigan in the transitional forest. And Gloria, she likes to shoot little videos. She's never seen this. So this is some of her videos, and
watch out for the snow. I think something San Diego in Arizona. Look, 1 foot of snow.
and take a bow. One warm round of applause there. Okay, we can take it. Reggie, we got to start getting ready for the mighty Rodin, and his demonstration. It's going to take a little bit to set up. So